Welcome to my YouTube channel, Me and Mind Machine Learning. This is the static tutorial series. This is the statics second day. So today I will discuss the very important topic of statics. If you are beginners, you should learn the what is the range, variance, and standard deviations. It is the alphabetical three alphabetical sequence of statics. So now come to the what is the range. Basically, what is the range? Range is the defined as the difference between the maximum and minimum value. It means that in your data set contain the maximum contain the various value, show the difference between the maximum and minimum value, give the range. Now, that is your set 10, 16 and 19, 13 is the minimum value is the 10 as shown in your data, and maximum value is the 27 shown in your data. Now what is the range? So the range is the 27 minus 10 minus 10 as far as the definition of range is the difference between the maximum and minimum value. Show maximum value is the 27 and minimum value is the 10. Okay, now it's a very important note, yeah, important point of the range. What do you mean by range? What the application of range? Range give the two different aspect of your data. If a large range value indicate the greater dispersion in data, it means that your data is not so closely, the data is so far. And another aspect, if a small range indicate that there is a less dispersion in the data, it means that your data is so close. So now it means then one questions come in your brain, come in your mind, what do you mean by dispersion? If you are a beginner, then you should know what do you mean by dispersion, but already you have learned in statics, then you are friendly with the words dispersion. Dispersion means spreading in data, like in your data sets 10, 16, 19, 13 and 27. That is the variation 10 to 6, 6 to 3 and 19 to 13, 13 to 27. This is the spreading of your data. So it's a simply meaning of spreading our data. Now come to the variance. What is the variance? Variance name simply say variance measure the how far data set is spread out. It means that like a butterfly, if a butterfly move either and thither and spread in a particular room, so variance give the measure how one butterfly move from one to another. That is a simple real life example of variance. But uh, in your data set, variance is the give the concept of average of a square difference from the mean. Average difference from the mean. What do you mean by? So first of all, you find the mean of your data. Now subtracting the mean from each number in the data set, squaring the result and average the square difference, that give the variance. So finally conclude the what is the mathematical formula of variance. Mathematical formula of variance is the sigma square summation x minus mu whole square divided n. This formula represent the four populations. So what is the mathematical formula for the sample? For population same as a sample, but denominator part it's become n minus 1. Why? Because due to the degree of freedom lost in a sample by the time calculating the variance due to the extraction of the substitution of sample. It means that when you extract the variance, when you extract the sample by calculating the variance, that's lose the one value, so n minus 1. Okay, There is so no need to more emphasize on variance, because Python is sufficient to perform any kind of calculations. Only you need to gain the concept, what is the backdrop of variance, what is the background of variance in your applications. That's why only you need to focus on the concept of variance, and nothing, calculation is nothing. Even you using the Excel and any min tab, or you can easily calculate the variance. So but Python is a very friendly, even you want to become a data science, yeah, ML engineer, anyway, anything else. So Python is a very friendly language. So don't worry, we will perform the coding part in a Python. Now come to the standard deviation. What do you mean by the standard deviation? If you got the concept of variance, then it's a simple root square of square root of a variance is called standard deviations. So what is the mathematical formula of standard deviations? As under root summation x minus x bar whole square divided n. Okay, so that is the same as a variance, but it is the square root of variance. So what do you mean by the standard deviations? Basically, a standard deviation gives the concept of the how much closer to your a mean value. Means that if a standard vary means that a standard deviations is only used to measure the spread or dispersion around the mean of data. It means that your standard deviation is the move either and either of your mean value. Means that it's a standard deviation is the neighbor of mean value. If a standard deviation is the larger, then means that its neighbor of mean value is the extended. And if a standard deviation is the closer, means that its neighbor is the very close. So it means that if you have to calculate the standard deviation practically, a standard deviations is never negative. That's why there is a very interesting fact, but uh, there is no need to for the why standard deviation is never negative. What is the application of a standard deviation? Why the real interpretation of a standard deviation is never negative in your real life? It's very interesting. Now it means that if you find the standard deviation of means, so it's easily to sensitive to outliers. Means that outliers may be impacted on our standard deviations. It's impacted by outliers. So a standard deviation is sensitive to outliers. So now all this part have covered. Theoretical aspect is the completed. Now come to the Python coding. So open your Jupyter notebook and let's perform in a Python. This is the coding part of our range, variation and standard deviations. So it's a first of all we have to import the NumPy for a numerical analysis, and another package is the statics for statics, like import variance and standard deviations. So first of all we take the data np.array. Okay, and now come to the how to calculate the range. So range is the definition of to maximum to minimum, difference between maximum and minimum. So maximum value is the 98 and minimum value is the 25. Axis define the row, and now okay, so 98 minus 25, that is 73. So range is the 73. Now calculate the variance. So simply you have to variance df, it's give the variance. Okay, that is the 599, the sample variance. Now come to the standard deviation. STDV is the package, and DF, that's give a 24 into 47. So it is the coding part. If you understand the theoretical aspect of range, variation and standard deviations, then you practice the coding of range, variance and standard deviation. Thank you for watching this video.